Okay. Okay, good afternoon, ladies and gentlemen. We're going to go over these quick review exercises. I see you've been working on these. On this one here, number one, what did you get for a domain?
Negative infinity, 2, 3, negative 3, union, negative 3 to infinity.
And this is one that you probably, I hope, did anybody do this without a calculator?
No.
Well, you really could have done this without a calculator, right? Because you could have wrote x plus 3 is not equal to 0, so x is not equal to negative 3, right? You could have done that without a calculator, right?
Yeah.
Okay. So next, 2. What did you get for this one?
1 to infinity.
So Angel, was it bracket 1 or parentheses 1? Bracket 1. Okay, any insights anybody had? That's what you got?
Second that.
Okay, this is related to one of the parent functions we went over last week. Remember we had this one, the ln(x) function, remember that one?
Yeah.
And so I'm going to show it to you briefly, and we're going to describe what happens here. I'm just showing you how you could have solved this without a calculator. Okay, so remember this was the ln function, right? You remember that from last week? So what was the domain of this function right here?
0 to infinity.
0 to infinity, okay?
There you go.
0 to infinity, but what does this minus 1 do? Shifts over, right? So when we shift over to the right, we're going to have this looking thing here. What is our vertical asymptote now?
1.
X equals 1.
X equals 2.
So based on this, would this be a bracket or a parentheses?
Parentheses.
Probably be a parentheses, right? Anybody get that?
Yep.
Yeah. I got
Angel, do you see why we have a parentheses and not a bracket?
Because it's not actually on.
Yeah.
It's just there. It's approaching it.
Approaching, okay. All right, very good. So now we're all right, right? Okay, good. Let's go on to this one here. What did you get for this one?
Parentheses, negative, infinity, comma, 5, parentheses.
Parentheses. Okay, let's talk about what it looks like here. Okay, if we go like this, okay, we have this negative t. So what does that negative t do? Okay, negative t puts it over like this, right?
Bracket.
So bracket, you say?
Yeah.
Okay, so if we move this to the right, 1, 2, 3, 4, 5. So this is what it should look like, right?
Yeah.
And so this is the point 5, 0, 5 comma 0. And so this should be what over here? This should be a bracket, right?
A bracket, I mean.
Okay? All right, any questions on this one?
Nope.
Okay. Now, this one, for 4, what did you get for a domain on this one?
We didn't get that one.
You didn't get it?
I got a 1 to infinity.
1 to infinity?
1 to infinity.
1?
On my
Bracket 1 or parentheses 1?
Parentheses 1. I put bracket.
On my calculator.
Bracket.
It's before 1.
Before 1?
See,
That's like approaching.
bracket.
Okay, let's go ahead and work this out, because on your calculator, you may not be able to see it very well. What do we have to do to this denominator and square roots here?
Square.
We have to say 2x
Yeah.
minus 1 is what?
Not equal to 0.
Not equal to, but
Can't be negative.
cannot be negative. So we write this as greater than 0.
Hey, look. Huh? Oh, sorry.
So now if we go ahead and solve this, what do we get here?
You get
2x is greater, well, it's supposed to be 2x, right? 2x is greater than 1. And so what is this going to be?
X
X
is greater than a half.
greater than 1/2. So what's going to go here?
A half.
A half, right? And it's going to be bracket or parentheses.
Bracket.
Parentheses.
Parentheses.
Greater than, that's a parentheses, right?
Yeah, that's what I'm.
So 1/2. So this should be it here, right? Who got this one here? Okay, good. All right, 5. This one here, absolute value of ln(x). What is this one going to be?
1 and 2 infinity.
Okay,
Oh,
bracket 1 or parentheses 1?
bracket. No, parentheses. Bracket. Bracket and then.
Then parentheses. Why is this a bracket, not a parentheses?
Because it's on the point. Yeah, stop there.
Okay, let's go ahead and I want to show you, this is again related to that parent function we talked about earlier, right? So what happens, so this is the original parent function. Okay, what happens to when we're below the x-axis here? What happens to this when we're below the x-axis? We have the square root of what? Square root of negative number. Is a square root of negative number defined? No, not as a real number. And so the function doesn't really start being defined until x equals 1. And so when you graph the thing, you should see something like this, right?
Yep.
And a square root will will flatten this out even more. But so that's what it should look like. Okay. Next, this one here for 6. What did you get?
6, -1.
Bracket -1 or parentheses?
Bracket on bracket.
Bracket. And this is one of the ones I started to talk about a little bit. I think it was the very last thing I talked about on Friday. Remember I talked about the equation for a circle? Remember I talked about that? That's what this one is, where r is equal to 1. So if you solve for y, you're going to end up getting y is equal to plus or minus 1 minus x squared. So this is just going to be, all this is going to be is a semicircle. This is going to be the semicircle with a radius of 1. And did anybody solve this algebraically, like 1 minus x squared is greater than or equal to 1? Anybody do that?
No.
Well, you could have done it. You'd have 1 is greater than or equal to x squared. So x squared is less than or equal to 1. And then you take the square root of both sides, and what do you get? You get x. X is less than 1, and x is greater than -1, which is this, right? Okay. Next, 7.
Wait, so what did you get?
This is our domain here for this one. Okay. Yeah, oh, it should be equal to. Yeah, less than or equal to, greater than. So, all right. This one here for 7. What is our domain?
Bracket.
Bracket what?
-3.
For number 7?
I think so.
To what?
I got infinity, but I don't know.
Yeah, I got
Infinity? Yeah. What this one should be, this one should be all real numbers.
It's opposite of, well, that's right.
Does it? Okay, what do you know about what's in the denominator here? You got this t squared plus 1, right? So what do you know about t squared plus 1? Can t squared plus 1 ever be 0? No. And so can we have a discontinuity in this function? No, we can't. So there are no discontinuities. Most of the time you see a variable in the denominator, you'll have a discontinuity, except if you have like this, where it can't be equal to 0. Because if you have t squared plus 1 is not equal to 0, then you'll have t squared is not equal to -1, right? And so t is going to be equal to what? plus or minus square root of negative 1. Well, what's the square root of negative 1? Not real, unreal number, so it's I, right? Yeah, so this will be like plus or minus I. Square root of negative 1 is the imaginary number I. So this one does not exist, therefore you can't have your denominator equal to 0, okay? Next, this one here, what did you get for this one here? 8.
Excluding 0.
Yeah, I didn't get that. I got an exclusion of 0. And this is what I got. I don't know if that's what you got, Will, but I got this one right here. 0,
Yep.
union, 0, comma, infinity. Why is that?
Because it dips down and...
Yeah, dips. So what it is, you remember we had again, the parent function of natural logarithm. We had this thing here, right? And then when you go ahead and do the absolute value thing, makes it go like this, right? But what do you have? You have a vertical asymptote here. So the thing is never going to be 0. So if you put this in your calculator, you would see, like in your table, you'd see undefined value at x equals 0, okay? So this would be our answer for number 8. Anybody else catch that besides Will? Okay.
I guess I need to start with that too.
Yeah. Okay, this one here, what'd you get for its domain here for this guy? So negative 1 to 1,
Yes.
parentheses or bracket?
Parentheses.
Why is this one a parentheses and not a bracket?
Because it doesn't actually touch the line.
Yeah, and why it does not touch? Why it doesn't touch? What do you see here that makes this the case? What do you see in this?
Can equal 1 or negative 1.
Okay, what it is? Okay, this has to be. Remember the other one we had? 1 minus x squared is greater than or equal to 0, right? But this one is what? It's greater than 0. Why is this going to be greater than 0 instead?
It's square root, so it can't be negative.
Okay, no, the reason is we can't have this be 0. When it's in the numerator, this can be 0. When it's here in the denominator, it cannot be 0. So that's why we have this instead of the brackets, okay? And last one we have, our domain is what? All real numbers. Okay, so that's that one. Okay. I'm going to want you to have your name on that and hand it in. But I want you to get ready to take some notes here. We're going to talk about compositions of functions today. Does anybody know what a composition of functions is?
Sounds familiar?
Does it sound familiar?
Don't remember.
Well, I remember from Algebra 2 class last year, this was one of the things that we actually could have possibly talked about in Algebra 2 class, but did not.
Good stick.
Okay? So we're going to introduce this via something called a function machine approach. Okay. Here's the function. Has anybody ever seen these things called function machines? Have you ever seen function machines like this before?
No,
Kaylee says she has.
I've never seen that.
Okay.
This looks like a square letter. Square letter.
Square letter. Okay, I'm gonna show you what happens. Okay, we're gonna take. I'm gonna let this in blue. We'll say let x equal 5. Okay, and then we're gonna run let x equals 5 through the function machine, and we're gonna get an output here. For output, we'll say f of 5 is equal to 10. Okay, and now with this 10, we're going to bring this 10 here, right over here, and use it for the input of x here, and we're going to end up getting g of 10 is equal to 101. Okay? So we start here, the function operates on 5, spits out a 10. We take this 10 over here and we spit out 101. So the way we say this is g of f of 5 is going to be equal to 101. So basically what g and f do, it's a combination of functions. Starts out, we take this 5, run it through this f here, and then the 5 out here is changed into a 10, and then the 10 goes through the g and becomes 101. Okay? And sometimes you'll see this written as g. You have this little circle looking thing here. G-O, it looks like G-O-F, but it's kind of a superscript. 5 is another way you can write it. So these are notations that you will see sometimes. So g of f of 5, or g, looks like G-O-F of 5. Okay? Does that make any sense?
Yeah.
Okay. Well, we're going to get some examples of that. Now we're going to go the opposite direction. We're going to input, we'll say let x equal 6. Okay? And we're going to put 6 through here, and we're going to say g of 6 equals 37. And then we take this 37 right here, and we run this 37 through this thing right here, and we're going to get f of 37 is going to be equal to 74. Okay? And so the way we would articulate this, just kind of summarize this, would be f of g of 6 is going to be equal to 74, or we could alternatively write this as f of g of 6 equals 74. So these are just alternative ways of describing what they are. Okay, now that I've done this, I want to tell you what these functions are that made this happen. Anybody figure out what the functions are? Okay, I'll tell you what they are. The functions are, this one here is going to be f of x is equal to 2x. And this one over here is going to be g of x is equal to x squared plus 1. Okay? And look at those numbers and see if that makes sense now. Does that make sense? Because we took this 5, and 2 times 5 is 10, right? Then we bring this 10 over here, and what's 10 squared plus 1? 101, right?
Yeah.
Then we take, alternatively, we take the 6 and we plug 6 in here, and what is 6 squared plus 1? 37, and we take this 37 all the way up here, and we get 37 times 2, which is 74. Okay? Now I want to show you something that you can also do on this. You can take, I'm going to go to this function machine here, and we're going to still keep the same values here, I mean the same functions. We're going to say g of x is equal to x squared plus 1, and f of x is equal to 2x. Okay, what we're going to do is we're going to find f of g of x. So in other words, what we're doing is we're not going to plug the numbers through here, we're going to actually find the function. All right? So how do we find f of g of x? Well, you take this g of x here, right? So what that is, that's going to be equal to f of x squared plus 1, right? What do we do with this x squared plus 1? It's going to be f of what? 2 times x squared plus 1. Does that make sense? So we're taking this x here becomes g of x. So we're taking this thing right here and replacing x with g of x, which is x squared plus 1. And so we multiply that by 2, so we would say our answer here would be 2x squared plus 2, right? Okay, now let's try what we use. Remember we tried 6? If we put 6 in here, what do we get? 2 times 6 squared is what? Well, what's 6 squared? 36, right? So 36 times 2 is 72, and 72 plus 2 is 74. So that checks, right? So this is where we can call this also FOG of x. Okay, next, let's go ahead the opposite direction. We're going to find g of f of x, right? And how would we do this? How would we run this operation through here to find g of f of x? It's equal to g of what? Two x, right? So what we'll do is we're going to take 2x plus 1, right? G of 2x plus 1. And what's g of 2x plus 1?
Wait, why is it plus 1?
Oh, it's just 2x, excuse me. It's just, I got the 1 here, it's g of 2x, excuse me. Thanks for catching that. So what is this going to be here? It's going to be g of, what do we do with this x? How do we find g of 2x? If we plug 2x into here, what do we have? Well, we're going to have 2x squared plus 1. Is that right?
Yes.
Let me put it, actually it's going to be 2x squared plus 1. I'll make sure the notation's easy. So what do we have when we multiply this out? We get what? 4x squared plus 1, right? So that's going to be our GOF of x. Okay?
Mr. Terrell, I'm sorry to interrupt you, but I need y'all to leave your things where they are and step out in the hallway for a moment.
Okay. Okay, class. Just to finish up class. Okay, what we have here, when we plug in 5, what do we get? What's 5 squared?
25.
25 times 4 is 100, 101. The last thing here is this thing right here. Okay, the two graphs. What if we have f of g of 2? How do you find f of g of 2?
Magic.
Okay, where's the 2 go first? With the g, right? So the g comes up here, and what do we get here?
9.
We get about 9, it's roughly 9. If we take this 9, what do we get over here? Take this 9, what do we get here? We bring this 9 up here, we get 9. So that's going to be equal to 9. What about g of f of 3? What is that going to be?
Going to be,
So we take this 3 up here to 7, right?
yeah,
And what do we do with this 7? Wrap it here. And what do we get here?
3.5.
So yeah, it could be about 3.5 or 4. We'll say 3.5. But so we can do composition of functions with graphs and tables, so forth. All right.